Perfect. Hi, guys. This is the Ruby Mob. Today on 17th of May 2018. Nice to see Kevin and I. It's just the two of us, sad. Okay, I'm going to share my screen and then we're going to randomize. Okay, so I am going to take you through today. Ololo. And today we'll be doing. What will we be doing? I was there and I moved. Oh, we'll be doing including a module more than once. Crafty, in one way or another, I can hear you. Yeah, including a module more than. Oh yeah, it's defining. So it's up here. Yeah. Oh, sorry. We're looking at defining the same method more than once. Okay, so what are methods in Ruby? In Ruby, a method is anything that alters an object's behavior or an object's attributes. So whenever we want an object to behave differently, we usually pass a method to it. So let me show you a brief example of a method. Okay, Crafty was disturbing me, I'm sorry. I just shared some very classified information. Awesome. So IRB, yes, that's what I was looking for. So we're going to create a random class, call it, Sigu, you're making noise in some way. And let's call it Getty. Getty with one E, please. All right. And then in here, let's define a method called play. And in that method, let's put is just simply printing. I am playing. Perfect. Then we end the method and we end our class. So whenever we create an instance of this class, how do we create an instance? We call, Kevin can tell us how we create instances.
Oh, you have ended class first before you
Sorry?
You have not, you're still in the class.
No, I've ended it twice.
Oh.
Yeah.
So we create instances by calling the new method of the class.
Okay, the new method on the class. So let's say a random variable, maybe real, equals Getty dot new. By doing this, we're creating a new instance of the class Getty. Of the class Getty, and we're assigning it to the variable real, whatever that is. There. And now we want to call this method onto the real object so that real is able to play. So we want to change the behavior of real. So we do rew dot play. This should display I am playing because that's what we've told it to display in this particular method. Sorry. There we go. So that's exactly what methods do in Ruby. So the topic that we're looking at today is defining the same method more than once. So I think this is more of overriding. So you can go through. Yes, Kevin?
Okay, so this section we were doing. This section was about modules. This section was about modules. So this section is defining the same method more than once. We are just going to look at what happens, like in the method lookup, when you have a method that is in the module and another method in the class.
Okay, awesome.
If you have a class that has a method that is already in module, so what happens? So that's what this section is. That bit of defining the method more than once.
All right. Awesome. Thank you, Kevin. Okay, so we can quickly go through what this guy is talking about. So as we've learned in chapter 3, that if you define a method twice inside the same class, the second definition takes precedence over the first. This is more of overriding. So when I have two methods in the same class that have the same name, the last one that we've defined will have precedence over the first one. So if at all I am calling that method on any object, it will consider the last method that I've defined since there's two of them or more. The same is true for modules. The rule comes down to this. There can only be one method of a given name per class or per module at any given time. If you have a method called if you have a method called calculate interest in your bank account class, then you write a second method called calculate interest in the same class, the class forgets about the first version of the method and instead it takes the last one, right? So that's how classes and modules keep house. But when we flip an object's eye view, the question of having access to two or more methods with the same name becomes involved. So an object's methods can come from any number of classes or modules. True, any one class or module can have calculate interest. This means that I can have a class that inherits from another class, and that class, the parent class, can have the method calculate interest, and our current class can also have that method. Or I can have a module appended or included inside my class, and that module has the name, the method calculate interest, and my class also has the method calculate interest. So what we're looking at today is the precedence or the lookup. Which method will Ruby first look to, or will Ruby have precedence over when it comes to defining methods that have the same name? Yeah. Okay, so but an object can have multiple calculate interest methods in its method lookup path, because the method lookup path passes through multiple classes and modules, just as I have explained. So still the rule for objects is analogous to the rule for classes and modules. An object can see only one version of a method with a given name at a given time. If the object's method lookup path includes two or more same named methods, the first one encountered is the winner. So having many methods is something that is usually common when it comes to inheritance and maybe prepending and including modules. So how an object looks or how an object considers a method, that's what we're going to be looking at today. So the next listing shows a case where two versions of a method lie on an object's method lookup path, one in the object's class and one in a module mixed in by that class. Okay. Sorry, let me go down. There. So we have a module that is called interest bearing. And inside this module, we've defined a method that is called calculate interest. And whenever we call this method, we're asking it to put placeholder. We are in module interest bearing. And then we end this method. And then we also end our module. Then after that, we also have a class called bank account. And in our class, we include this module that we've defined up here, which is called interest bearing. And then within the same class, after including the module, we also have another method with the same name called calculate interest. And in here, we put these three things, placeholder, and we're overriding, which was defined, yeah? Okay, so after that, they're only creating instances of the class and then calling the method on it. So after looking at this and the brief description, we can try this in the terminal, right? Okay. So let's create a module. We have a module called random. I love using the word random. And does it have a method? Yeah, inside this module, we have a method called, it's called calculate interest. And we're asking it to put anything, literally. And we end that, and we end that. Then, oh, sorry, what? Random is not a module. Oh, okay. I had defined a class called random before. Yes, I think so. Yes. So let's do random dot class just to find out. It's actually a class. Now, I think while I was running my tests on IRB, I had defined random as a class before. So we can use another name. Or Kevin, did you have something to say? Okay. So we can use module randomer. And then we have def calculate interest. We put anything and then we end and we end again. Awesome. Now we have a module randomer. And then we could have a class that is called we call our class randomist. Perfect. And in this class, we want to include the module that we've just created above. So we include randomer. Random. You found it. Oh, so Kevin has something to share. He can. Okay, let me just finish this and then he shares it with us. And then also within the class, we have the same a method with the same name, which is calculate interest, but this is putting something different. Any other thing. Awesome. And then we end. Sorry. And again. Okay, Kevin.
Oh, so you are getting the random is not a module error. It's also not. It's not because you defined it, but Ruby has the random class. Ruby has a random class. I was just checking in the Ruby doc. Yeah, random number generator. So from the random classes where you have the like random method, this is where the random method comes from. Yeah.
Thank you so much, Kevin. All right, so random. The reason why random refused here is because random is already a predefined class in Ruby, right? Yeah, so that's why. I'm sorry for the misinformation. Okay, so we want to create a new instance of a class. Okay, Kevin, tell me why we can't create a new instance of this module. We talked about it earlier today. Oh, earlier last week.
Okay, so uh, we cannot create instances of random or not of random. Well, let me say of module random because you'll find that in let me say if you look at the module class, the new is not available on the modules, so you cannot instantiate them. Yeah.
Thank you, Kevin. So the reason why we can't call new on module or we can't create a new instance of a module is because modules are usually instanceless. So we can't ever create an instance of module. But modules are only used for altering attributes of a given object or defining methods. Yeah. But a class can always have instances. Yes, Kevin?
Okay, so but we can create a new module. We can create a new module by calling new one the module class, but we cannot instantiate a module like yeah. Are you, yeah.
We can do module with a capital M dot new, but we can't do a module class dot new. Okay. Oh, sorry, what? Oh, we can always. So we can always do this. When we do this, we're creating a new module. Get this right. We're creating a new module. We're not creating an instance of a module. This should work. But if I have my module here, like randomer, and we want to do randomer dot new, This will fail because we can't usually create a new instance of a module. We can only use .new to create a module. I hope that's clear.
Yeah, or let me say, in modules, new is a class method. It's not an instance method.
Makes a lot of sense. Thank you. All right. So let's go back to this. So we have why am I even using my touchpad? We have our module randomer, right? It has the method calculate interest that puts this, and then we have our class randomest that includes the module randomer that has this method. But then inside our class, we also have a method defined with the same name but doing something different. So we want to create a new instance of this class and call this method on it, calculate interest. So calculate interest has been defined twice, first in the module and in the class where we're also including the module. So we want to create a new instance of class randomist. So what we do is free. That's just a random variable. And then we do randomist.new. Sorry. So we've just created a new instance of this class, right? And we want to call the, what is it called? Calculate interest method onto this particular object that we have. Let me do that. Did I need to do that? No. Okay. Well, there. Okay. So, what do you expect our output to be? Kevin, it's just me and you. Yeah.
Okay, so in this case, I'm expecting the output to be any other thing. I'm expecting the output to be any other thing.
Why?
How the way probably not probably the way method lookup will go here. So it will first check if the free where we are calling it will first check for what is this free. You'll find that it's an instance of a class and the class is randomness. Then it will now check for the message you're sending. This message is calculate interest. The way now it will check for, so the message is calculate interest. The first lookup or way it will look for the method first is in the class. It will check if this calculate interest, is it now an instance method in the randomest class? And if it goes there, it will get, yes, there is an instance method, which is, it should output any other thing. So that is what it will execute first.
One way to find out. Awesome. Yes. So the display that we get is for the class and not the module. Because when an object starts looking for its method in the method lookup path, it begins with the class from which it has been defined. And if it doesn't find that method in the class, it looks if this method includes a module. And if it does, it takes that method for that module. If it's not in the module, it checks whether this class is a subclass to another class, and it also checks in the parent and the grandparent and the great grandparent, and it goes on and on and on. Yes. So there we are. So we can go back to our document that I lost. Awesome. So this is what we get. So when you run this listing, you get the following output. So the output that we get is here. But this was defined in the class rather than in the module. Yeah. So that makes a lot of sense. All right. So two calculate interest methods lie on a method lookup path of an object C. but the lookup hits the class bank account before it hits the module interest bearing. Therefore, the report method it executes is one defined in the bank account. So it looks in the class first before it can look in the module. So an object may have two methods with the same name on its method lookup path in another circumstance where a class mixes in two or more modules. More than one implements the method being searched for. In such a case, the modules are searched in reverse order of inclusion. That is, the most recently mixed in module is searched first. If the most recently mixed in modules happen to contain the method with the same name as a method in the module that was mixed in earlier, the version of the method in the newly mixed in module takes precedence because the new model is closer on the object's method lookup path. So what this statement is trying to say is that if we're including more than one module into a class, yeah, so we can always do an example. Create another class called A. Sorry, actually could start with modules. Create a module that is called A and define any method in it, tree. The spelling is bad. And we put this is a tree. We end that and that. Then we create another module B. And in there we also have a method with the same name, which is tree, and we put this is the second tree. We end that and we also end our module. And then we have another random class and we call this C. Oh, yeah. Yes, actually, I blundered on this module, so I'm going to have to use another module. So let's use another module. I have misspelled puts here. That's why I need to use another module. Just to be clear, I know what I'm doing. So def tree. And I put there. This is tree. Awesome. And I end that. So we have two modules that you're working with. I'd like for you to assume this one because I made an error here. So we are working with module B and module C. Now let's create a class D that includes both modules. So let's say include B and include C. And this class also, should it have it? No, I'll leave it like that. Awesome. So when we create a new instance of class D, which we create like tw equals d.new, this is creating a new instance of this class, right? And then we want to call the method on this particular instance, this method that is common in all of them, which is called tree. So that book is telling us that the output that we get here will be the output of the last module that was included in this class, which is C. So if we had a module B, C, D, E, the last one that will be included, which is module E, that's what the output will display. So we have the method tree that is common in all of the two modules, but it is going to take the last, what is it? It's going to output the last result of the last module that we've included, which is C. So we're expecting our output to be this. This is tree. Perfect. All right. So so that's exactly what they're talking about here. So we have a module M with the report method. We have another module N with the same method name. And then we have a class C that's including M and N. So whenever we tell any object in class C to whenever we call the report method on any object of class C, it's going to output the result of the last included module, which is N. And N says report method in module N. And that is our result here. Awesome. I hope that topic is clear. If there's any questions, Kevin, you can ask. All right.
No questions.
All right. Awesome. So, there's this, including a module more than once. So we have instances where we can include the same method, the same module more than once. So for example, you see in this class D, we already had two modules. We had B and we had C. So how about we included B, we included C, and we included B again? We can always try with a class, probably G, and then we include B, we include C, and we include B again. Now, if I define a method, if I define a new object of class G, why do I use commas? Yeah, and then we call the method tree on this. So do you think it will consider the value in, do you think it will output B because B is the last one and it has been repeated, or it will output the value, the result in module C? Kevin?
So in this case, it will output the instance method in module C, because we had already included B, so B is already in the method lookup path. So including it again won't change anything. So in this case, being that B is already included, already in the method, it will go to execute the instance method in module C.
All right, awesome. Thank you, Kevin. So what we're expecting should be the result that is printed in the module C. So we're still expecting this is tree rather than this is the second tree. Awesome. So we are on the right track. So anytime you include a module more than once in a class, say, it will always consider the first one. It won't look at the second one as a re-inclusion of the same module. It will just consider the first one. So yeah, that's it for that. Then we have the prepend method. So what the prepend method does, it's same as include, but when we use include, an instance of any class, or I can say an object, will first look into the class and then look into any module that is included into that class. But when we're using prepend, it's first going to look at the module first before looking at the class. So prepend works the same as include, only that it reverses the method lookup. So prepend looks at module first before class, and include looks at class first before module. So we can always try. Create yet another, what? Should I use a module? Yeah, module. Call this S. Dev pp, whatever that is. Put free and right, and another module. I have typos, and we call this R. And with def, we define another method. Same method, actually. Okay, different method, but the same method name. And we put caged. Awesome. And we end that. And then in our class, we call it Y. and we include S, and instead let's prepend R. Yes, and in this class we should also have a method called pp, and we put I'm in the class. Awesome. All right, so a brief lookup of what we've done. We've defined a module S, and inside the module we've declared a method called pp, and anytime we call this method, this is what we want it to print. And we've defined another module R. Inside we've declared the same method named pp, and inside this is what we want it to print. We've declared a class Y, and inside we've included the module S, and we've prepended the module R. But still inside the Y class, we have the same method named pp, but it puts something different. Now we want to create an instance of the class. You could call it Q and say y.new. This is how we create a new instance of a class. And then we want to call the method pp on Q. So we do q.pp. This doesn't make any sense, but anyway. So what we're expecting here is that since we've used prepend, and prepend tells the object to look into this module first before looking into the class, we're expecting it to print out what is in module R, which is caged, right? So yeah, that's what we have. So anytime we prepend, it has to look at the method, the module we've prepended first before looking into the class or any other module that is attached to it. So that's exactly what prepend does for us. That's what's been explained here. So this prepend, yeah. So you can use prepend when you want a module's. Yes, Kevin?
I think the upper bit they were talking about how you can confirm the method lookup using just you can see the difference between.
You can see the difference between include and prepend reflect both in figure 4.2 and in the list of a class's ancestors, which means all the classes and modules where an instance of a class will search for methods listed in order. Here are the ancestors of class person. Okay, you can see the difference between include and prepend reflected on figure 4.2. Where is this figure? Is there a figure anywhere? I don't see it. Okay, and in the list of our class's ancestors, which means all the classes and modules where an instance of the class will search for methods listed in order. Here are the ancestors of person class from the last example in IRB. So this is what you were saying we do, the ancestors thing.
Oh, as in you are talking of how you can you are talking of an instance and the class and the module first before the class. So if you use the ancestors method, you can see when you use include for the ancestors of that class, you will notice there is change in order compared to when you prepare the module. You will notice the change in order that the ancestors method will return.
I don't get you.
Okay, let me try to share my screen.
Okay. We can switch to your screen.
So assume we have
Mhm.
something. Okay. And then I have a
Mhm.
and I include this module A. Yeah. So in this case, if I check for data data transistors, transistors, notice the order here, it first starts with B. So
Mhm.
if you are calling pre-created an instance as B, pre-created an instance as here called for
So,
example. So the way it will look first is such that this person first in the class B. Then if it's not here, it will check it in the module.
mhm.
Then it will check it in the superclass
Object.
of B, which is object. Assume this is subscribe for the pretty print, then kernel, then basic objects. Yeah.
Mhm.
Okay, but when we have another type C and
Mhm.
prepare,
Prepend A. Yeah.
and create an instance of C and call
Print some.
so in this case, the way the limit is we're expecting uh,
No, you're okay. Or you could have used a method in the class.
then I have a class B that includes A, and it also has a method PR test.
Mhm. Mhm.
And we call this. So in
Yeah.
this case, the before I call the method, before I just produce the class, just to see how the method looks to go, it will first start with the class B, then the module. So in this case, if I call b.pr, it will first check if this method is in the class B, and you can notice it is in the class B. So this is the output expecting. Yeah? And in the class B. But when I have another let me say another class C, and I prepare A, then I have the method clearing, and prepares class C. Then that
Start all over again.
C,
Pen A.
sequence.
Awesome.
This is the same thing here. Oh, actually, before ordinary messages first,
Dot
then
ancestors.
so notice the ancestors here. It will first start with we have instantiated C and we want to call the PR method. But notice here the ancestors we first start with A, which is the module, and like up here we're including where it first gets for B, which is the class. So in this case, it first starts in the module. So in this case, if we go here on this, we are expecting it will first go to the module, and the module A has this something here. Yeah, yeah. So that's basically what the ancestor method was doing. Okay.
All right. Thank you so much, Kevin. That actually makes sense. I could have skipped that part, by the way. Thank you. All right. So this is what Kevin was talking about. Where have I gone? Here. So now it makes sense when I read this. You can see the difference between include and prepend reflected both in figure, wherever this figure is, and in the list of classes ancestors, which means that all classes and modules where an instance of the class will search for methods listed in order. So when we search for ancestors, we find the method lookup path for where the object on that class will look. So as you've seen, as he was sharing, whenever we use prepend, it begins with the module that is included in that class, then the class, then the object and the basic object and all that. But when we use include, it begins with the class. So it searches from the class first before you could go to any module that has been included into that class. All right. So now that. So of course this is the same thing. So you can use prepend when you want a module's version of one or more methods to take precedence over the versions defined in a given class. Yeah. So we can use prepend when we want the method inside the module to override the method that is currently in the class. So as mentioned earlier, prepend is new in Ruby 2.0. You won't use it much, at least not yet, but it's useful to know it's there, both so that you can use it if you need it, and so you'll know what it means if you encounter it in someone else's code. So it's just important to know it, although it's not that much used. Okay, so we have a summary here. So the basic rules governing method lookup and ordering the search method path. To resolve a message into a method, an object looks for the method in all this that have been mentioned here. So it looks for a method in modules prepended to its class, just as we've included and prepended modules in reverse order of prepending. Yeah. It looks into its class, the class where that object has been instantiated from. Modules included in its class in reverse order of inclusion. So this is using include, this is using prepend. Yeah. Modules prepended to its superclass. It looks also at the modules that the parent class has. Its class is superclass. It also looks at the superclass of its class or the superclass of its class. Those are the parents and the grandparents. Yeah. It also looks at modules included into its superclass. Yeah. It looks at the modules that have both been included and prepended into its superclass. It looks at the modules that have been included and prepended it to its class. It looks at its class. It looks at its superclass. So this is basically what an object does. It's like a spoiled child. Like if it doesn't get anything on its class, like where the parent is, if the parent doesn't give it what it wants, it goes to anything that the parent has included, which is a module. If it doesn't get it there, it goes to its grandparents and that and that and that. Yeah. So particularly this is, we should go through this before our time is up. So generally, this is how an object can. Oh, this is the figure 4.2 they were talking about. I didn't know it was way down here. So we have our object here. It's called object actually, yeah. And this object is an instance of the class D. So we have our class here. So class D has a new object called object. Class D inherits from class C. So anytime we thought in class, this is where it goes. It goes to the method, sorry, it goes to the module P, yeah, and searches for that method there. So anytime oh, sorry. So module P, let's say, is included into the class D, and the class D also inherits from the class C. So this is how the lookup goes. It goes to the module and then to the class C. And module C has prepended module P and has included module M. The prepend, we said it looks to the module first before it can look to the class that's in. So if this object comes here and doesn't find its method, it's going to look to P. And if it doesn't find its method at P, it's going to look at class C. If it doesn't find it at C, it's going to look at module M. Yeah. If it doesn't find it at M, it continues to go higher and higher on the method lookup, which is the kernel, then the basic object, and so on and so forth. So this is exactly what this diagram is about. So it says an instance of class D looks for methods X in its method search path across both included and prepended modules. All right. So we have a simple pink box here that we can summarize with. You're familiar with chapter 3 with the singleton method, a method defined directly on an object. A singleton method is a method defined directly on an object. So like we have this def object, which is a def object.talk. We could have just written def talk, which is an instance method. But when we're talking about a singleton method, only this object is eligible to use this particular method. So, and you may wonder where in the method lookup path singleton methods lie. Actually, even I didn't know. The answer is that they lie in a special class, really, created for the sole purposes of containing them. The object singleton class. There's an object singleton class. That's new. We'll look at the singleton classes in detail later in the book, at which point we'll sort them into method lookup model. Okay, so that's convincing. We'll probably look at it later. So a somewhat specialized but useful and common technique is available for navigating the lookup path, which is the keyword super. So I'm thinking we'll get to super next time. Kevin, do you have something to add? You look disturbed.
I'm okay. So, we will try to. No. Probably will. I was curious on how a singleton method will work. How a single method will work. I'm not sure how a single method will work. If we define singleton.
I actually don't know, but I'm thinking.
Because in the lookup we are checking for if the class has singleton methods, but it doesn't have it fixed to the methods. So
All right. I'm actually surprised that they're talking about method lookup in singleton methods, because I'm thinking, how can we have this object, right? Let's say it belongs to a certain class, and its singleton method is talk. And then we look to its parent class, and we also find a singleton object, a singleton method with the same method name. I don't know. Anyway, he says we'll look at it later, so we'll probably have more detail in the long run. Okay, this has been fun. Thank you, Kevin. So next time we're going to be looking at going up the method search path with super. There's a keyword super that's Awesome. It does wonders. So we'll look at that next, which is on Monday. All right. Thank you, people. Bye.
Bye bye.
Bye.